So we're starting 5.3 today. 5.3 today is nonlinear systems. So we're back to just two variables, so back to just x and y, just two dimensions, but this time they're not necessarily linear equations. We will look at circles and parabolas as well. Okay, so first just kind of visualizing what some of these solutions will look like. So if you have a circle and a line, okay, it's possible then to have two solutions. So that's two different ordered pairs. Two different ordered pairs that you would get. You would have two x values and two y values. Or you could just have one solution. And it's also possible to have no solutions. You could have other types of systems, and this is just the way it looks. It's actually a circle and another circle. So that's possible to have four solutions. We could have parabolas. So you could have a parabola with a line and has two solutions. You could have a circle with a parabola and have four solutions. You could have a circle and a parabola with three solutions. You could have a circle and a parabola with two solutions, and a circle with a parabola with just one solution. You could also have no solution if your circle is here and your parabola is here. Okay. So, circle and a parabola have up to four solutions. So each one of those solutions represents a separate ordered pair. Alright, so let's practice solving, and we'll first start by solving with substitution. Which equation would I want to use to substitute, the top or the bottom? The top, because I can get a variable by itself easier on the top. What is not true, let me just show you real quick. If, let's say you looked at the bottom, that is not true. That does not work like that. You can't square root an expression and square root each term. You can't distribute an exponent when there's a plus sign. Okay? So that is false. Yeah. If it was y squared plus or times 100, yes. Okay, so I need to do the top, and I'm going to get x by itself, so I'll subtract the 7y. And I'm choosing x because that's the easy one. And then I take this and I plug it into the second equation for x. Okay. What we should have said at the beginning is let's talk about what my equations represent, so I have an idea of how many solutions I have. So the top equation is what type? Yeah, linear. And what about the bottom one? What do we think the second one is? No? So quadratics have a squared term, but only one of the terms is squared. This has x squared and y squared. So what would this one be? We have graphed these. Circle. Yes, a circle. Okay, so a line in a circle, I know it can intersect 2 times, 1 time, or 0 times. So I'm going to think about that as I solve. All right, now back to where I have this binomial squared here, this negative 7y plus 50 squared. So to do that part, it is incorrect to do this. You cannot distribute an exponent when you're adding. Remember, that is wrong. So you can either, to the side, write it twice and FOIL, or remember your shortcut for a binomial square. Okay, so that's what I will use, but you can always take it to the side and FOIL. Okay, so my A is negative 7y and my B is 50. So when I square negative 7y, first of all, when you square a negative, it's positive. 7 squared is 49. And then you're squaring the y also, so y squared. The next part, 2ab. So you've got to multiply these together, negative 7y and 50, and then times 2. So negative 7y times 50 is negative 350, good, times 2. Good, negative 700y. Good. And then b squared. So 50 squared is good. Okay. Let's combine our like terms. So that gives me 50y squared and then minus 700y. 500 equals 100. Now the equation is quadratic because I just have one term that's squared, just the y. So to solve a quadratic, we want one side equal to 0 and then factor or use quadratic formula. So I'm going to subtract the 100. Okay, so these are pretty big numbers. So if you'd like to go ahead and do quadratic formula, you can. But I do know that it could factor. What can I do to make the factoring easier? Yeah, factor out 50, because 50 goes into all three of those first. So let's factor out 50. So 50 times what gives you 700? 14, good. And then 50 times what gives you 2400? 48. So remember, when you're solving and you take out a common factor, it will just cancel out because 0 divided by 50 is still 0. Okay, so if you have a common factor that you factor out, it will cancel out. So I only need to focus on this trinomial. Okay, so what multiplies to give me positive 48 and adds to be negative 14? Good, negative 6 and negative 8. So y equals 6 and y equals 8. That is two different y values. I have two different y values here. So I need to find our corresponding x values. These are not in order paired together because they're both y. So you can choose either equation to plug it back into. The linear one is probably the easier one. So that's x plus 7 times 6 equals 50. So that's 42. So x equals 8. So I do have the solution 8, 6, but not because my second y value was 8. The second y value being 8 really does not make this x value 8. It really doesn't have anything to do with this x. All right, so I have 1 point at 8, 6. X was 8, y was 6. Okay, let's do the same thing for 8. So negative 6. So then I have another point at negative 6, 8. You want to check these are right. Plug them both in to both equations, okay, to check. And they should be true, okay, for both. And those are my solutions. Like how 6 was paired with 8. It's just a coincidence. Okay. So let's take this same system and let's see what it looks like on a graph. Okay, let's try to graph this now. Any questions about this first? Okay. So we first want to identify what my equations are. So we already said this top one was linear. So when you graph a linear function, you want it in slope-intercept form, which means get y by itself. You want it y equals mx plus b. So subtract x from both sides and divide by 7. So negative x over 7, that's like a negative 1x over 7. So negative 1/7 x. And then 50 divided by 7 is just 50 over 7. Okay, so I'm going to go ahead and graph the line. So 50 over 7 is just a little bit over 7. A little bit more than 7. Okay, and then my slope is negative 1/7, so down 1 and right 7. Or up 1 and left. Okay. So I have to try to graph this as accurate as possible. I know what my solutions are because I already solved this algebraically. But let's say we didn't know, so you have to try your best to graph it as accurate as possible. Okay, we said our second equation was a circle. So to graph a circle, we graph the center and the radius. So remember standard form of a circle. We have graphed circles in here. Okay, we did that a couple times last semester. So what's my center? 0, 0. There is nothing with the x and y, so my center is 0, 0. What's my radius? 10. So start at 0, 0 for your center. And then you want to go left, right, up, down, 10 units. And draw your circle around those points. So do just the best you can. I can tell you right now, mine is not going to look very good. Going this big is difficult. It kind of helps that I know where the line should intersect. That's actually not too terrible for me on this graph. So I think we can see then. We intersect here and here, and I hope I have this right. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So 8, 6. That was one of our points, right? 8, 6, and negative 6, 8. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, when I did this in third hour, when I drew my circle, I had not done so good over here, And so I did not get this point, negative 68. So I'm going to fix my circle. That being said, if you don't know what your answers are, because if you haven't done it algebraically first, pick where you think they intersect and plug them in. If they work, then you know you got it right. If they don't, then you need to go back and fix your graph. Okay? Question?
Will it always be
An integer? Yes. Yes. They will be whole numbers, like where they should intersect. Okay? Okay. Okay. I want to use elimination. And the only variable that can eliminate, and I'll have to multiply, but the only variable I can eliminate will be the x's because they're like terms, x squared and x squared. I can't eliminate a y and a y squared. I also cannot change an equation so it has an exponent. I can't add an exponent. Like I can't do this, you know, where you would try to do this. That doesn't work. Doesn't work like that. So I have to do x, which means I need to rearrange, because when you do elimination, everything has to be lined up. And then I'm also going to multiply this top one by 2, so then I get, because 2 times a negative 1/2 is negative 1. Okay. And then I'll write that down here. So 2 times negative 1/2 x is negative 1x. And then 2 times y, and then negative 2.
Why multiply the top x? Why don't we just multiply the bottom by half?
You could do that, but then you have more fractions to deal with. That would work. If I see a fraction, I'm going to multiply by something to get rid of the fraction. Okay, so now I can add these, and the x squareds eliminate. They're like terms and they're opposites. Okay, y squared and 2y, those are not like terms, right? So you can't combine them. The only thing you can do is just write them next to each other, and then you get 63. I have a quadratic, so what should I do? Good. Get it equal to 0, and then factor or use quadratic formula. This one is already pretty easy to factor. What multiplies to be negative 63 and adds to be positive 2? Good. Positive 9 and negative 7. So y equals negative 9 and y equals 7. So 2 y values. We need to plug those back in. Let's take a second to look at our equations. The top one is quadratic, so you just have one squared term. You just have x squared, okay? The y is not squared. So that's quadratic. The second one is a circle because you have 2 squared terms. So a parabola and a circle, as we saw at the beginning, could intersect 0, 1, 2, 3, or 4 times. So it's possible to get up to 4 solutions. So let's plug in, and I think the circle equation looks easier than the quadratic because There's no fractions or negatives even that I'm dealing with. So I'm going to use the circle equation. And I'm going to plug negative 9 in first. And a y. So negative 9 squared is positive 81. 65 minus 81 is negative 16. Okay? What's the square root of negative 16? Yeah, well, plus or minus, but you cannot graph imaginary numbers. Okay, so that is not a solution. So negative 9 is not going to be part of my solution. Okay, do the same thing with 7. So this is positive 16, so x equals plus or minus 4. So I have two x values for that one y value. So that's 2 points, 4, 7, and negative 4, 7. But this is how you could get 4 solutions. Like if this one hadn't been imaginary, you would have had 2 x values to go with that y coordinate and 2 x values to go with the y coordinate of 7. Okay? Okay. So that's where we'll stop.